Hello, welcome back. This is Calculus by Dr. Oz. Today we're going to have a practice for the application of the root test. We have four hand-picked exercises. Before we start the video, let me have a quick run-through of the root test, even though I will explain that within the video again. So a root test, similar to the ratio test, is applied to infinite series with non-zero terms. This time, instead of checking the ratio of two consecutive terms of the sequence, the nth term of the infinite series, what we're checking is the nth root of the absolute value of the nth term of the infinite series. So nth root of absolute value of an as n approaches infinity is what we're checking. And we have three major cases: absolute convergency, divergency, and inconclusiveness. And these are determined by the limit value. Okay? If the limit value is strictly less than 1, then the series converges absolutely. And if it's greater than 1 or even infinity, or when we call it like doesn't exist, then the infinite series diverges. And like in the ratio test, the test is inconclusive and the limit is exactly equal to 1. This is the most unfortunate case because you apply all the, or you check all the limits of an, the nth root of an, and you get 1, and then that means there is no conclusion here. So you have to try other tests to deduce about the convergency of the infinite series. I have 4 hand-picked exercises to go through, and I'm going to split this video into 4, and I will handle each sub-question in a different video to make the videos a little bit shorter. All right, so let's get started.
The very first example is the infinite series n minus 2 divided by 5n plus 1 raised to the power of n. So here we go. What we're going to do here is to look at the nth root of the absolute value of an. So let's grab an first. Okay, an is equal to n minus 2 5n plus 1 raised to the power of n. Okay. So here we go. The absolute value of an, and this is the nth root. Okay. So nth root, absolute value of n minus 2, 5n plus 1. Okay. Raised to the power of n. Okay. And that is equal to n minus 2 is the absolute value raised to the power of n. And then 5n plus 1 absolute value raised to the power of n. Okay. You can also do this in one shot, that the nth root of the nth power is just the absolute value. So let's just do it in one shot if you don't mind. So this is n minus 2, 5n plus 1. Okay, so nth root of the nth power of an expression is just that expression in the absolute value. Okay. In fact, when you take the absolute value of this, maybe I should have had explained that. Let me just rewrite this part better. So it is in fact the absolute value of n minus 2, 5n plus 1 raised to the power of n, but you can also always put the absolute value inside as the way I did. Let me just put one more step here to be very clear for you. So it is equal to n minus 2, 5n plus 1 absolute value to the power of n. That's something that we use in algebra. That's how we sort of like put the absolute value inside that expression. Okay. All right. So what I'm going to do here is taking the limit of this expression. Okay. N minus 2, 5n plus 1. Okay. Well, n approaches infinity, so the top and the bottom is going to be positive anyway. So why don't we get rid of the absolute value for now? Right. And this is infinity over infinity because top and the bottom has n related terms in it. So why don't we use the L'Hopital's rule once? Okay, so the derivative of the top is 1, the derivative of the bottom is 5. So this is the limit of a constant that is 1 over 5. All right, that's our lucky day because when the limit is less than 1, the series converges absolutely, and this is the case here. Okay, so I can go ahead and then say like this converges absolutely. Okay.